Morning to all of you. Myself Amit Sharma. I am PGT Chemistry and today I am along with a very important topic of organic chemistry. Today we will discuss about the first chapter of 12th standard. The chapter name is Haloalkanes and Haloarenes, or we can call it alkyl halide or aryl halide. As we know that it is one of the most important topic of organic chemistry because it is the beginning. So let's come to the topic. The topic name is haloalkane and haloarene. The another name of this chapter is alkyl halide or aryl halide. As per the topic is, this topic is very important for 12th standard, for competitive exams and along with other relevant exams. Dear students, the first segment or the first chapter of organic chemistry, which is including the halogen compounds. As we know that halogens are the 17 group elements of our periodic table. The modern periodic table or the newest periodic table contains 18 groups, and out of these 18 groups we discuss about 17. The 17 group of modern periodic table, which contains fluorine, chlorine, bromine, iodine. These elements are having two specific nature. One, they can form salt. Because of salt forming nature, they are called halogens. Halo is somehow relevant to salt formation, and salt formation nature is making them halogens. So fluorine, chlorine, bromine, iodine. These 17 group elements which are having salt forming nature, and apart of that they are also having colored vapor formation. Because of these two natures, these are called halogens. So fluorine, chlorine, bromine, iodine, if attached to carbon atom, then they will somehow produce haloalkanes or haloarenes. We will discuss about that one by one. The fluorine, as we know that fluorine is the most important element in whole periodic table because of its high electronegative value. We know that fluorine is the most electronegative element in whole periodic table. As Pauling said, it contains 4.0 value of electron negativity. So the electron negativity of fluorine is most, and that's why we call it black sheep. The question has been asked in a board exam as well as competitive exam, which element is called black sheep. Because of very high electronegative value, we call fluorine as black sheep. I hope you also know about the fluorosis disease. The disease fluorosis, which is arised because of excess amount of fluorine within the water, that is also including fluorine. Fluorine is also important for our teeth and bones. As we know that the toothpaste and the things which we use as a cleansing agent for our teeth are also contain fluorine. So fluorine is most electronegative element. Second, it is also called black sheep. The another thing is chlorine. Chlorine is also very important element. It is a non-metal and it is a gas. Fluorine is also gas, chlorine is also gas. So chlorine is used as a decolorizing element. Chlorine gas remove the color from the substances, and if you have studied in 11th standard, it contains most electron affinity or electron gain enthalpy. Electropositivity value of chlorine is maximum. Electron negativity of fluorine is maximum. Chlorine contains most electron affinity. Bromine is the only element in the periodic table from the non-metal side which is found in liquid state. It's a very important question. Bromine is found in liquid state at room temperature. So it is the only non-metal which is found in liquid state at room temperature. Another element which is mercury, that is the only metal which is found in liquid state at room temperature. Now we talk about the iodine. Iodine is the only solid in this halogen group. Bromine was liquid, chlorine and fluorine was a gas. So iodine is solid in nature. Iodine is one of the famous halogen because it is basically used in several chemicals. If you can recall the chemical called AgI, silver iodide. Silver iodide is one of the chemical which is used to produce artificial rain. So AgI is used over there. Iodine is solid in nature and it is sublimating in nature. It can turn from solid to gas directly. So we have also used that in tincture iodine. We also use that in iodoform. So these are some of the important applications of halogens. So these all elements are called halogens, and uniformly they are indicated by X. So now come to the point. The name haloalkane haloarene are somehow sounding that if we are having an hydrocarbon, and from that hydrocarbon hydrogen is replaced by any one of these halogens. I mean, if hydrogen is replaced by any one of the halogen, means halogen is somehow replacing hydrogen, then we will get Rx. This group of chemicals which contains halogen along with the carbon chain are called haloalkanes. And if halogen is attached to aromatic ring, for example, we are having benzene as a prominent example. Suppose that we are indicating hydrogen over here, and in this particular condition, this hydrogen is removed and halogen is replacing it, then we will get this kind of situation. So this particular compound where hydrogen is replaced by halogen, we call it haloarene. So if we are talking about haloalkanes, then this will be the particular kind of compound. If we are discussing about haloarenes, then this will be the particular sense of compound. So basically haloalkanes and haloarenes are those halogen derivatives of hydrocarbons. If you will see, hydrogen of hydrocarbon is replaced by halogen and we will get Rx kind of compound or ARX. We can also represent that by ARX, where AR is indicating the aromatic chain, aromatic ring, and X is indicating the halogen. So basically haloalkanes and haloarenes are introduced by such manner. The most important thing is how they are important to our life. Whenever you are studying any chapter, whether it is of physics, it is of chemistry, it is of biology, or it is from anywhere of the syllabus, you should know about the reason to read it. Why we are studying it? Why there is a need to study this particular chapter? Actually, because of the part of the syllabus, you need to study it. Apart of that, this chapter which you are studying is somehow relevant to your life directly. I can give you some examples. There is a very famous example of freons. Have you ever heard about freons? Freons are those chlorofluorocarbon compounds which are used in the refrigerator as a gas, in air conditioners, and in different refrigerating substances or equipments. We are having several chemicals used as a medicine. If you can recall Dettol. Dettol is one of the very common antiseptic which we generally use in our day-to-day life. That Dettol is also contains these kind of compounds. Dettol, which is basically containing two components, it has been asked in board exam, chloroxylenol and terpenol. These compounds are somehow having the relevance from this chapter. Have you ever heard about DDT? Para dichloro diphenyl trichloroethane. This DDT is one of the best seller insecticide at a day. Nowadays in some countries it is totally banned. In developing countries it is still used. So that DDT, which is dichloro diphenyl trichloroethane, is also the part of this chapter. Have you ever heard about benzene hexachloride? Actually there is a chemical called benzene hexachloride, BHC, also commonly called lindane, or we call it 666. These chemicals are also used as an insecticide. So what we can assume over here, this chapter is very highly relevant to our day-to-day life. I hope a chemical is well known to you. You definitely know the name of this chemical. It is chloroform. Have you ever heard about chloroform? Chloroform is one of the most, you can say, famous chemical of chemistry, organic chemistry. This is used as an anesthetic. Anesthetic are those chemicals which are used to use as an anesthesia. So anesthetic substance, chloroform, it is also the part of this chapter. So when you talk about the chloroform, when you talk about the DDT, when you talk about the BHC, when you talk about the other refrigerating substances like freon, these all are from the same chapter. One most important chemical is still remaining, that is carbon tetrachloride. One more important chemical, carbon tetrachloride, CCl4, which is commercially called pyrene. This chemical is majorly used in dry cleaning. This chemical is also used as a organic solvent, and this carbon tetrachloride is also used as fire extinguisher. So these all chemicals, whether it is DDT, whether it is BSC, whether it is Dettol, whether that is chlorofluorocarbon, whether that is chloroform, or it is carbon tetrachloride, these all are somehow produced by the same chapter. So these are the applications of this chapter. Haloalkanes and haloarenes are giving you such kind of chemicals. Some other medicines are also used by that. So we'll go along with the chapter regarding that. So whenever you are starting any organic chemistry chapter, then the first portion or the first topic of index will be introduction. So as per the introduction of haloalkanes, we have covered it. Haloalkanes are those organic compounds in which halogen is replacing hydrogen of alkane or hydrocarbon group, and that's why we call it alkyl halide or haloalkanes. When the hydrogen atom of aromatic ring like benzene, if it is replaced by halogen, then we are getting haloarenes. So haloalkanes and haloarenes, these are the two groups of this chapter. You can study them separately, you can study them together. In common nomenclature, we call that alkyl halide and aryl. So this was the introduction of the chapter. Now we will discuss about the next portion, and that is the classification of alkyl halide or aryl halide. How we can classify alkyl halide and aryl halide, that is the another topic. So now talking about the classification, in 12th exam or in competitive exam, several times it has been asked, and the question can be asked straightly or in some other method. So now we are discussing about the classification of elements. Classification. When we are classifying any compound or anything, then we need some basis. As we have indicated alkyl halide by Rx men, so now we can classify them on the basis of three things. First, we can classify them on the basis of halogen number. So the first kind of classification of alkyl halide is on the basis of halogen. On the basis of X number. On the basis of halogen atom number, you can classify that in initial level. The second, we can classify alkyl halide on the basis of this carbon nature to which halogen is attached. On the basis of carbon nature. What we are studying? We are studying the nature of the classification of alkyl halide, and alkyl halides can be classified on the basis of halogen atom number. We can classify that on the basis of carbon atom nature, or we can classify that on the basis of this carbon halogen bond nature. So the next basis of classification can be carbon halogen bond nature, and it is the most important kind of classification which is generally asked in exam. So now what is the next topic? Next topic is classification of alkyl halide. Alkyl halides can be classified in three categories. The first one on the basis of halogen atom, the second on the basis of carbon nature, and the third we can classify them on the basis of carbon halogen bond nature. So now talk about the first one on the basis of halogen number. What it is indicating? It is indicating you that halogen number, as per increase, the alkyl halide will also change. So now we are discussing about the first one. The first one is a mono halo derivatives. Mono halo derivatives are those kind of alkyl halides in which only one halogen is present. As we can discuss about methyl that is X methyl halide. Here we can have chlorine, that will be methyl fluoride, chlorine, methyl chloride, bromide, and iodide. So whenever you are having only one halogen, then in that condition you call that mono halo derivative. So only one halogen is there. If we are having fluorine over there, it will be methyl fluoride. If we are having chlorine over there, it will be methyl chloride. If it is bromine, then methyl bromide. And if we are having iodine, it will be methyl iodide. So the first category within on the basis of halogen atom number is mono halo derivatives, where only one halogen atom is present. Number of halogen will be, number of X atoms will be only one. Okay, so methyl fluoride, methyl chloride, methyl bromide, and methyl iodide, they can be example of this category. The next one, if we are having two halogen atoms, then we call it dihalo derivative. Dihalo derivatives are having at least two halogen atoms. Number of halogen atoms in this category will be 2. Let's talk about the example. As we discussed about two halogen atoms, we can have CS2X2. I mean, you can have CS2Cl2. You can have CS2Br2. You can have CS2I2. If you are watching all these examples, or you are having example like this one, if you are talking about this kind of example, we are having two halogen atoms over here. When we are having two halogen atoms, it will be categorized in dihalo derivatives. But both the halogen atoms are present on the same carbon. Whenever we are having two halogen atoms, it will be categorized in dihalo derivatives. But both the halogens are present on the same carbon. Then we call that geminal, or in short, we call that geminal dihaloalkane. What we are discussing over here, when we are having two halogen atoms and both the halogen atoms are present at the same carbon, we call that geminal or gem dihaloalkanes. If we are having two halogens but both the halogens are connected to carbon atom or attached to carbon atom, adjacent conditions. Suppose that we are having this one. Over here we are also having two halogen atoms. If you can see it closely, there are two chlorine atoms, so we are categorizing that into dihalo derivative or dihaloalkanes. Both the halogen atoms are present at adjacent carbon, alpha beta carbon. So whenever you are having two halogen atoms attached to alpha beta positions or at 1 2 position, then we call that vicinal dihaloalkanes or dialkyl. So what we are discussing right now, we are discussing about the classification of alkyl halides, or the first category was on the basis of halogen atoms. If halogen is only one, then we call it monoalkyl halide or monohalo derivative. The example of that can be represented by CH3X. Here we can have CH3F, CH3Cl, CH3Br or CH3L. If we are having two halogen atoms, when we will call that dihalo derivatives or dialkyl halides. We can have example like CH2Cl2. This is called methylene chloride, methylene bromide, methylene iodide, and so on. If two halogen atoms are present, but both the halogen atoms are on the same carbon, then we call that geminal dihaloalkane or geminal dialkyl halide. That's a very important point. If two halogen atoms are present on adjacent carbon, like this one, if we are having this condition, we are having one halogen at the first one and the another chlorine is on the second one. This kind of situation are called vicinal, or in short we call that vis dialkyl halide or vis dihaloalkanes. So that is the another kind of question which can be asked in exam. The third category in the dihalo derivative is when we are having two halogen atoms but those are present on first or last, means they are having attachment on either first carbon or on the last carbon. In Greek alphabets, we are having for first one we are having alpha word, for the last one we are having omega. So such kind of haloalkanes in which we are having two halogen, so that will be categorized in dihalo derivatives. But both the halogens are present on first and last. In this particular condition, when we are having two halogens but both are present on first and last, we call that alpha omega dihaloalkane. So we call that alpha omega dihaloalkane, or you can call that alpha omega dialkyl. So dear students, we are discussing about the classification of alkyl halide, and in this classification we are categorizing them on the basis of three manners. The first one is on the basis of halogen. In that we are having subcategories. The first is monohalo derivatives, second is dihalo derivatives. In this dihalo derivatives we are having three subcategories. First is geminal, second is vicinal, and the third one is alpha omega. Several times examiner has asked questions from these kind of examples. Now the third one is if we are having three halogen atom, we call that trihalo derivative. As the name is indicating, we are having at least three halogen atoms. The number of halogen atoms will be at least 3. And this category is making some important examples. Like for example, we are having CHX3. It can be the representative form. Here we are having 3 halogens. So especially this category of compound are called haloform. We will discuss about a very important reaction when we will discuss about the chemical reactions of alkyl halides. Then haloform reaction is a very important reaction. So we are having the first one. So the most important thing is when we are having 3 halogen atoms, then we call that trihalo derivatives. Trihalo derivatives are generally represented by CHX3 form. and it is one of the most important kind of organic compound found within this chapter. Tri-halo compounds are called haloform. If we are replacing this X with fluorine, then we got CHF. This is called fluoroform because we are having fluorine and the basic structure is from haloform, so we call that fluoroform. If we are replacing that with chlorine, then it will be chloroform. The most important compound which we have earlier discussed, chloroform. Chloroform is used as an anesthetic, and it is a very important to know that chloroform should not kept openly in contact of air and light. It has been asked several times in the examination. Suppose that you are having a bottle of chloroform and in laboratory we are using that as a chemical. Suppose that someone because of any default, because of intentionally or unintentionally, he has opened the cap of the tip or cap of the chloroform bottle and it is coming in contact of air and light. What would happen? If chloroform is directly coming in contact of light and air, then the air oxygen react with chloroform and turn it into a poisonous gas which is called phosgene. The compound of the chemical formula of phosgene is COCl2. Dear students, you should know about a very important fact that COCl2 is chemically called carbonyl chloride. So we are discussing about the poisonous gas, that is phosgene, and this phosgene is chemically called carbonyl chloride. If I am not wrong, it has been asked in examination. What is the chemical name of phosgene? It is carbonyl chloride. So carbonyl chloride or the phosgene, which is a poisonous nature containing gas, is formed, and this phosgene can even cause the death. So we should keep it in closed container, in colored bottle, and always away from the light and air. So phosgene is the product of chloroform reacting with oxygen. So that is one of the most important thing. Chloroform is also used in formation of several medicines. It is also used in formation of freon. It is also used in formation of some other chemicals and as a solvent of organic chemistry. So we should know about the chloroform because it is one of the most important or interesting topic of organic chemistry or from this chapter. Now coming to the third one, if we are having three halogens in form of bromine, then it will be CHBr3. It is called bromoform. There is no very important concept or point about it. When we are having iodine in place of that, then it turns into CHI3. And the CHI3 is also a very important compound. This CHI3 is called iodoform, and it has been asked in exam. Iodoform. Dear students, iodoform is a very important organic compound because it is used as an antiseptic. What does that mean by antiseptic? Antiseptics chemicals or the medicines are those medicines which are externally used on skin. As the term is indicating, anti, I mean it is somehow opposite, and it is opposite to septa or septic. So we call it antiseptic. Antiseptic cream, lotion or medicines are those medicines which are applied outside the skin, and these are used to fill the wounds. So antiseptic iodoform is used as an antiseptic, and the chemical formula of that is CHI3. But there was a negative point about iodoform. The smell of iodoform was not tolerable. Iodoform is a very good antiseptic, no doubt at all. It fills the wounds very fastly. It is very good for the skin, but it is having improper smell. It is having malodor. When a compound is having malodor, it is not tolerable. So in place of that, it has been asked in examination, you should be aware about it. In today's time, iodoform is replaced by tincture iodine. Tincture iodine is also an antiseptic. Actually, it was discussed and concluded that iodine is basically the component which is having the wound filling capacity. So tincture iodine is nowadays used. What is tincture iodine? It is also an antiseptic. It is also used iodine, but along with iodine we are using ethanol with that. Ethanol is also a very important compound used in organic chemistry. So the mixture of iodine and ethanol in a proper ratio is called tincture iodine. Here iodine will fill the wounds and ethanol will kill the germs. As you know that ethanol is used as a dehydrating substance. So it will dehydrate the bacteria or the germs. So it will kill the germs. It will make the surface disinfectant, and that iodine will fill the wounds. So tincture iodine is majorly used as an antiseptic nowadays. So we have discussed about tri-halo derivatives. When we are having three halogens, then we call that haloform, and the resultants or the examples of that are fluoroform. Chloroform is very important as we discuss about it. It produces phosgene, which is a poisonous gas. It is also used as a solvent. We have discussed about bromoform, and most important is iodoform. Iodoform is solid in nature. It is used as an antiseptic. Because of malodor, it has been replaced by tincture iodine, which is the mixture of ethanol and iodine. So that was about the trihalo derivatives. If the number of halogen atoms becomes more than 3, then we can go with the other names like tetra, penta, hexa, but conjointly we are calling them polyhaloderivatives. So the fourth subcategory on the basis of halogen number will be polyhaloderivatives. What is the fourth one? I am writing it over here. It is polyhaloderivatives. As the term is indicating, poly is many. If we are having number of halogen atoms more than 3, then we call it polyhaloderivatives. The number of halogen atoms will be greater than 3. I mean 4, 5, 6 and so on. So polyhaloderivatives are the fourth subcategory of this on the basis of halogen number classification. So now what are the examples of that? We are having a very famous example which we have earlier discussed, and that is chloroform. CX4 is the representative form. And we are having some examples of that. If the number of halogen atoms are more than 3, we call it polyhaloderivatives or polyalkyl. Representation is by CX4. We are having a very famous example, CCl4, carbon tetrachloride. Actually, we have discussed some important facts earlier. Carbon tetrachloride is categorized in polyhaloderivative. It is one of the very famous chemical in organic chemistry, as it is used in as a solvent. It is also used as fire extinguisher, and it is also used in dry cleaning. If you have heard about dry cleaning, the process of cleaning the clothes without the water is called dry cleaning, and over there we are using this chemical, carbon tetrachloride. Actually, the stains like ink, the stains like coffee, the stains like tea, which are having some organic compounds which do not easily leave the surface of cloth by water, can be removed, can be erased by using carbon tetrachloride, because it is one of the greatest kind of organic solvent. As it has been asked in examination, what is the dipole moment of carbon tetrachloride? Actually, 4 chlorine atoms are directly attached to carbon atom, and when 4 chlorine atoms are attached, every direction will have the same attraction. So the total dipole moment of carbon tetrachloride is 0. So it is very important. The organic solvent which contains 0 dipole moment will be the good one. So over here, carbon tetrachloride contains dipole moment, mu value is equal to 0. So it is one of the good kind of solvent. So if anybody is asking you about carbon tetrachloride, you should know 5 points. It is a polyhaloderivative. Number 2, it is a very good solvent. Dipole moment is 0. It is used in dry cleaning, and it is used as a fire extinguisher. Some other examples are also there, which we will discuss about within the chapter. Another example is DDT. DDT is also a kind of example where we are having more than 3 halogen atoms. Let's talk about that. DDT is a very important chemical because it was a famous insecticide in earlier times. There was a scientist called Paul Muller, and the famous laboratory, in his famous laboratory, he produced such compounds in artificial manner, and the full form of DDT is para dichloro diphenyl trichloro ethane. If you are watching the name, then we are having 3 chlorines over here and 2 chlorines over here. So ultimately we are having 5 chlorines. So you can easily categorize that in polyhaloderivatives. If we will discuss about the structure of that, we are having 2 chlorines on para positions. This is basically the para dichloro, and these are the diphenyl. Then we are having and we are fulfilling the valency of carbon. If you are watching this chemical, this is para dichloro. If you will put that in vertical form, both the chlorines will be in para position. So para dichloro diphenyl trichloro, and this one is ethane. So this is the chemical formula, structure of DDT. And if you are watching over here, we will discuss that in detail. Chlorine is 5 in number. and when we are having more than 3 we call it polyhaloderivatives. One more important example is remaining, and that is BHC. The full form of that is benzene hexachloride. This benzene hexachloride or BHC is also a very famous chemical. As we have discussed that DDT is an insecticide which kills the insect. Same, BHC is also an insecticide. It also used as an insect killing substance. Benzene hexachloride, the chemical structure will be, this will be the benzene, and on every corner we will get chlorine. And if you will see the formula, it is C6H6Cl6. If you are having the number of each atom, it is 666. So it is also called 666. Benzene hexachloride is categorized in polyhaloderivative. It contains more than 3 halogen. As we can see, here we are having 6 chlorines. So 6 carbon, 6 hydrogen, 6 chlorine. We call it 666. Commercially, it is called as lindane. So if we are discussing about the polyhaloderivative, DDT is there, BSC is there, and we are having carbon tetrachloride is there. BSC is called benzene hexachloride. We call it 666. It is also called lindane and also called gamexane. So we are having gamexane, lindane, all these are the names of same chemicals, and this is basically the one of the example of polyhaloderivatives. So if examiner is asking you which one from the following is not a polyhaloderivative, and the options are carbon tetrachloride, then the next one is BHC, the third one is DDT, and the fourth one is chloroform, then obviously chloroform is the correct one because that is the example of trihaloderivative. So dear students, we have discussed about the first category based on the number of halogen atoms, and there were 4 subcategories. Some examples were there. All the examples are going to be the part of the further chapter. We will discuss that in detail, and I hope you will definitely get each and every point crystalline clear. So keep learning, keep studying. Thanks a lot. So now we will discuss about the second basis of classification. As you know that we were discussing about the classification of haloalkanes or haloarenes. Now we have discussed about the first category based on the number of halogen atoms. The second category of classification of alkyl halide is on the basis of carbon nature. On the basis of carbon atom nature. As you know that carbon atom can be classified on the basis of the attached number of carbons. Suppose that we are having a carbon in hydrocarbon, and this carbon is attached with another one carbon. Like we are having an example of CH3, CH2, CH3. This is called propane. Or in this particular compound, if you are watching this one, this carbon is directly attached to another one carbon, so it will be categorized as 1 degree, or we call it primary. Whenever we are having a carbon atom attached to another one carbon, we call it 1 degree or primary carbon. If you are watching this one, it is also the primary or 1 degree carbon. So we are having this one and this one. We are having 2 primary carbons. And this one in the middle, if you are watching this one, this carbon is attached with this carbon and this carbon. So it will be 2 degree or secondary carbon. So now what we are discussing about, if the halogen atom is replacing the hydrogen from any one of the primary carbon, suppose that this hydrogen which is from the primary carbon or this hydrogen which is also the primary carbon hydrogen, if these hydrogens are replacing by halogen atom, then your result will be CH3, CH2, CH2 and halogen atom X. This kind of compounds in which halogen atom is replacing the primary carbon hydrogen or primary hydrogen, then we call that 1 degree or primary alkyl halides. Primary alkyl halides. So dear students, when we are discussing about the second basis of classification then the basis of classification is carbon atom nature. That is a very important thing. Carbon atom nature. Carbon atom can be categorized as 1 degree carbon, 2 degree carbon, 3 degree carbon, and quaternary carbon. 1 degree carbon will be that carbon which is attached to another one carbon. So here we are having two examples. These two are the primary carbons or 1 degree carbon. If you are replacing these hydrogens, any one of them, with the halogen, then you will get this kind of compound. It will be 1 degree or primary alkyl halide. Suppose that you are replacing the middle one hydrogen, I mean this one, then your result will be CH3, CH, halogen will be attached over here, and CH3. If you are watching this particular compound, here halogen atom is attached to this carbon, and this carbon is having two neighboring carbons. So whenever we are in such situation, we call it 2 degree carbon. We call it 2 degree, or we call it secondary. So 2 degree carbon or secondary carbon is there. And if halogen is attached to that, we call it 2 degree or secondary alkyl halide. Secondary alkyl halide. So dear students, it's a very easy to understand. If halogen is attached to primary carbon, then we call it primary alkyl halide. If it is attached to 2 degree carbon or secondary carbon, it is 2 degree alkyl halide. Suppose that we are having one more example like this one. And if we are watching this one, here this carbon atom which is in the middle one is attached to this carbon, and this carbon. So it is surrounded by three different carbon, directly attached to three different carbon. We call it 3 degree carbon, or it is called tertiary. Tertiary carbon. And when we are replacing the hydrogen of tertiary carbon and putting halogen, we call it tertiary alkyl halide. So it is very easy to understand. When halogen is attached to primary carbon, it will be primary alkyl halide. When it is attached to secondary carbon, it will be secondary alkyl halide. When it is attached to 3 degree carbon, it will be tertiary alkyl halide. When we discuss about the quaternary carbon will be the carbon which contains all the four different carbon atoms, like this one: CH3, 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 and CH3. If you are watching the middle one, this carbon is attached by this one, this one, this one, and this one. Four carbons are directly attached to the middle carbon. So this carbon will be 4 degree carbon, or you will call that quaternary carbon. So now what is to understand about? Quaternary carbon will be that carbon which is having four different carbon atoms. Four different carbon atoms are directly attached to this middle carbon. So 4 degree or quaternary carbon is that basically that carbon which is having four attached carbon atoms. So 4 degree carbon is possible, but we all know that carbon atoms contains 4 valency. All the 4 are fulfilled, then there is no expectation, there is no possibility of adding halogen atom. So we can easily say that quaternary carbon or 4 degree carbon is possible, but 4 degree alkyl halide is never ever possible, because we are having no other position to attach. So dear students, 1 degree carbon, 1 degree alkyl halide, 2 degree carbon, 2 degree alkyl halide, 3 degree carbon, 3 degree alkyl halide. But 4 degree carbon is possible, but 4 degree alkyl halide is not possible. So we have discussed, okay, these 1 degree, 2 degree, 3 degree will be used when we will discuss about the SN1 and SN2 mechanism, because that is going to be the important segment of this chapter. So on the basis of carbon atom, we have discussed about primary, secondary, tertiary, and quaternary carbon. Quaternary alkyl halide is not possible. So now let's discuss about the third one. The third basis of classification is the most important one, because that is generally asked in last year exams. As I can evaluate the last year exam papers, I can say you that if the question is going to be asked from this segment, from the classification segment, that is the favorite one. So the last basis of classification is on the basis of carbon. It is carbon halogen bond nature. Okay, so the last basis of classifying the alkyl halide is on the basis of carbon halogen bond nature. Carbon and halogen bond nature is controlled or justified on the basis of the attached group to this carbon. What is the mean by that? Let's discuss it. Suppose that the carbon is directly having the halogen, but this carbon atom is attached with another one carbon. And if you are fulfilling the valencies, there will be 2 hydrogen and it will be 1 hydrogen. You can write it once again. It will be CH2 double bond CH and X. The bond nature of this carbon and halogen is controlled or influenced by this carbon. Actually, the carbon which is attached to halogen atom, if you will get the hybridization of that, how we can calculate the hybridization? We can calculate the hybridization in organic chemistry on the basis of sigma bonds. If you will count the sigma bond, here will be a sigma bond, hydrogen will make sigma bond, and out of these two, one will be sigma. So 3 sigma bonds are present over there. So this will be the sp2 hybridized carbon. So the carbon to which halogen is attached is sp2 hybridized, and the neighboring carbon to that, which is this one, if you will calculate the hybridization of this one, 2 hydrogens are there, so 2 sigma bond, out of these two, one will be sigma, so it is also sp2 hybridized carbon. So if we will see this kind of flow, where halogen is attached to sp2 carbon, and this sp2 carbon is also attached with one more sp2 carbon, then we call that sp2x, or this segment of this kind of compounds are called vinyl. So we call that vinyl halide. So it is a very important fact. Vinyl halides contains halogen atom attached to sp2 carbon, which is also attached to one more sp2 carbon. So this category of compound is called vinyl halide. Now let's talk about the next one. Suppose that we are having halogen atom attached to a carbon. This carbon is attached with another one carbon and also one more carbon. If we are having this kind of flow, if you will fulfill the balances, CS2 will be there, CS will be there, CS2 will be there, next. If you will see that closely, halogen atom is attached to this carbon, and if you will discuss about the hybridization of this carbon, 2 hydrogens are there, so 2 sigma bond and 2 single bonds, I mean 2 more sigma bonds. So there we will have 4 sigma bonds, and the hybridization of that will be sp3. sp3 hybridized carbon is having halogen, and this sp3 hybridized carbon is also one more carbon which is having sigma, sigma and sigma, I mean sp2. So if the flow is like this one, halogen is attached to sp3 carbon, and this sp3 carbon is attached to one neighboring carbon contains sp2 hybridization. So such kind of flow or such kind of group of compounds are called allyl. So it will be allyl halide. Dear students, we are having two differences over here. Halogen is attached to sp3 carbon, which is attached to sp2 carbon. So this category of compound is called allyl halide. When we are having halogen atom attached to sp2 carbon, which is also attached to sp2 carbon, it will be vinyl halide. So first one will be vinyl halide, second will be allyl halide. When we will discuss about the chemical reaction, then you will come to know that the removal of this halogen or the replacement of this halogen will be easier. Will be if you will see this condition over here. We are having halogen. The lone pair of that, the halogen atom which is connected to carbon over here, and the halogen which is connected to carbon over here. The nature of both the carbons are different, so the chemical reaction or the reactivity nature will be different. So the nature of reactivity will be justified on the basis of this bond nature, which is going to be the part of chemical reactions segment. Coming to the third one, if we are discussing about the 3 carbons once again, we are having these 3 carbons. Halogen is attached over here, and over here we are having a triple bond condition. This one. If you are discussing about this one, this compound or this segment of compound is called propargyl. So here we are having one more hydrogen remaining. Here we are having 2 hydrogen. Here hydrogen atom is attached to sp1, 2 sigma 1, 3, and will be sp3. So hydrogen is attached to sp3 carbon. And this sp3 carbon is attached to one more carbon which is having 1 sigma and 1 sigma, I mean 2 sigma. So it is sp hybridized. So if halogen atom is attached to sp3 hybridized carbon, and which is having this is having a neighboring sp hybridized carbon, this kind of classification, this kind of group of compound are called propargyl. Propargyl. So it will be propargyl halide. We are categorizing or classifying the alkyl halide on the basis of carbon halogen nature. Carbon halogen bond nature is controlled or influenced by neighboring carbon hybridization. We have first category as vinyl halide, second one is as allyl halide, third one as propargyl halide, fourth one. The fourth category where we are having halogen atom that directly attached to aromatic ring. I mean this one. Suppose that we are having this one. This is the aromatic ring. We call it benzene. We are having a direct removal of hydrogen from here. Means we are replacing hydrogen with halogen. If you are watching this one, halogen atom is directly attached to ring, and the carbon at which the halogen is attached is sp2 hybridized. This condition where halogen atom is directly attached to aromatic ring is called aryl halide. What we call it? Aryl halide. So we have discussed about vinyl, we have discussed about allyl, we have discussed about propargyl, we have discussed about aryl. One more category is also remaining. Suppose that we are having an aromatic ring and halogen atom is also attached to that, but not directly. What I mean to say, halogen atom is attached to aromatic ring, but not directly. It is attached indirectly. For example, we are having this now. Can anyone guess about the name of this chemical? This is called toluene. Methyl benzene is called toluene. Here halogen atom is attached, but not directly. Halogen atom is replacing this sideways hydrogen and then attach it. So this category of compound where halogen atom is attached to the carbon contains sp3 hybridization and then to the aromatic ring. We call this particular category of compound as benzyl. So this category is called benzyl. So this is called benzyl halide. So dear students, we have discussed about the classification of alkyl halide or aryl halide on the basis of carbon halogen bond nature. Carbon halogen bond nature is influenced by neighboring carbon. We have discussed about vinyl halide, where halogen is attached to sp2 carbon, again which is attached to sp2 carbon. If halogen is attached to sp3 carbon, neighboring is sp, we call it propargyl. Halogen is attached to sp3 carbon, neighboring is sp2, we call it allyl. And when halogen atom is directly attached to aromatic ring, we call it aryl halide. And if it is attached in sideways form like this one, we call it benzyl halide. So these are the category present within the CX bond nature, and this was the whole about the classification of alkyl halide or aryl halide. A single mark question or a half mark question can be asked from here. It is one of the very important segment because from onward you will be able to understand the further concept. I request you all to get into the video, to watch the complete video so that you can get the sense of classification of alkyl halides, and I request you all to subscribe the channel CSC Education, and I wish you a very good luck. We will discuss about the remaining part within the next days. Yes, Esther.
First of all, I would like thank you, sir, for give us a very valuable and important time for our YouTube channel, CSC Education. So, sir, say something about our viewers for our YouTube channel.
Dear students, as we have discussed that I am the faculty of chemistry, and Chetan is one of the very close to me, and he has requested me for such kind of videos. I am promising you that we will continue these kind of videos for further academic education. And CSC Education, which Chetan is running nowadays, is one of the prominent institute which is providing a free of cost education to those students who really need that. In today's era, where we are having several kind of videos available on the net and YouTube and several other platforms, but I request you go for those topics, those videos which are relevant to your studies, and CSC Education is one of them, which are providing the prominent videos in good qualities with the good teachers, and they will definitely help you in your studies. So that is the whole which I request you to so that the persons like Chetan and the other which are making good efforts in academics for the free of cost educations. So please go with that. Thank you.
Okay, thank you so much, sir, again. And I just one request to all of you, my viewers, please like and subscribe our YouTube channel. The channel name is CSC Education. Okay, then thank you so much again.
Take care.